see even and odd signal properties with proof. Here these are the properties. Function of even and odd signal summary. First we are going to see sum of two even signal gives us even signal. We are going to prove that sum of two odd signals give odd signals. Sum of even and odd signals gives neither even or odd. Product of two even signals give even signals, and product of two odd signals gives odd product of two odd signals gives even signal, and product of even and odd signal gives odd signals. Now let's go ahead and see that. So first, for the proof, we are assigning xi of t as even signal, and for the even signal we know that xi of t, if you take negative of t, xi of negative t, actually for even signal, xi of t is equivalent to xi of negative t. If you solve, like if you watch my previous video, you see that like if you solve for example, if you have for signal function given, and if you solve for xi of negative t, you will get this one back. So that's why we have to consider the property. And for the odd signal, y of t gives negative y of t is equal to negative y of t. This one also, like if you have function of odd signal and if you substitute y of negative t for the t values, you will get this one, and that is equal to this one. Okay, so these are the two things we are going to use. And if you don't have any idea of this one, like how did we get this, it's better to watch my previous video. Like I have explained with examples of how to derive this. Okay, so these are the two things we are going to use in this video. So first one, we are going to see sum of two even signals is even signals. So for even signals, we are taking xi of t. So here xi of t plus xj of t, two even signals, we are adding them together, and we know that for the even signal, xi of t is equivalent to xi of negative t. So we can add xi of negative t, xi of and here we take the function also as z of negative t, and that's equal to xi of negative t, xg of negative t, and for the even signal, xi of negative t is equivalent to xi of t. So we can substitute that one back. So xi of t, xg of t, and that gives this function back. Okay, so from this one we know that sum of even signals is even. Now let's look at this one. The second one we are looking at is sum of two odd signals gives odd signal. So here we have the function z of t. We are adding two odd signals, ya of t, yj of t. The first step is we take the function in terms of negative t. If you do that, this is ya of negative t, yj of negative t. And for the odd signal, if you take ya of negative t, that gives you negative y of t. And if you take yj of negative t, that gives you minus yj of t. So here we are just adding, so this you can take the minus common. If you take the minus common, there is ya of t plus yj of t, and you can see this whole thing is equal to this c of t, because that's the one we had before. So instead of this, you can substitute c of t and minus z of t. This is the odd signal property, because when you substitute minus of t, if you get this one, that's the odd signal. Okay, if you substitute this and get the original like z of t, that's even. So this is an odd signal. So sum of odd signals is odd. And the third one, z of t is equal to xi of t plus yj of t. So here we are adding an even signal and odd signal, right? If we add an even signal and odd signal, let's see what we get. So here, to find out whether it's odd or even, we had first substitute minus of t for the t values, and xi of minus t plus yj of minus t. And for the even signal, if you substitute minus t instead of t, you will get this original one back, like xi of t back. Okay, and then if you substitute minus t for the odd signal, you will get minus of whatever the input you have, like a minus of this one, yg of t. So you can see this is not equivalent to z of t. Like z of t is x of t plus yj of t. So this is not equivalent to that. Even if you take the negative common, what happens is that one make this one negative. Like if you take the negative common, you have to make this x of t negative. So negative x of t plus yj of t, that's not the one we have. So we cannot have the odd or even. So since we are not getting odd or even signal, this is neither. Sum of even and odd is neither, not even, not odd. Now let's look at the fourth property. The fourth one, we are multiplying two even signals and see what we are getting. So here first we have to take the negative of t and substitute instead of t. So x of negative t, x of negative t. For the even signal, if you substitute negative of t, that gives you x of t. So you get this one, x of t, x of t, and that is equivalent to the one we have right here. So that is c of t. Instead of this one, you can substitute c of t. Therefore we are getting the z of t. Therefore this is an even signal. So product of even signal is even. Now let's do the fifth one, z of t, yi of t multiplied by yj of t. These two are odd signals, and when you multiply, what we get, like, so to see that we are substituting negative t instead of, like, we are putting negative t instead of t, and if you put that one, this y of t become y of negative t, yj of t become yj of negative t, and for the odd signal, if you substitute y of negative t, you will get negative y of t. So that's the one we get right here. And for yj of negative t, you will get minus yj of negative t. So like minus yj of t. That's the one we are getting right here. And when you multiply, minus minus cancels, because when you multiply two minus number, that becomes plus. So you get this one, yi of t, yj of t, and that's equal to this c of t. So if you are getting, when you substitute minus of t, and if you are getting the one with positive t without any negative sign, that's an even signal. So product of odd signal is even as well. Now let's look at this one. So here we are looking at z of t, x of t multiplied by yj of t. Here we are multiplying an even signal with an odd signal. And to find out whether we are getting the even signal or odd signal as a result, we can substitute minus of t instead of t. If we do that, this x of t become x of minus t, and yj of t become yj of minus t. And for the even signal, if you substitute x of minus t, that gives you x of t. So here we are getting x of t. And for the odd signal, if you put yj of negative t, that gives you minus yj of t. So that's what we are getting right here. And when you multiply these two, you know that the whole thing become negative. So x of t minus x of t, yj of t, and this is equal to this c of t. So minus c of t. And if you are getting a minus sign, that's an odd signal. So product of even and odd is odd. And that's it for this video, guys. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.